For this first problem, we'll go back to the David M. Lane applet. To find it, simply Google David M. Lane applet. Now we need to make sure that we are clicked on the second button right here, which will allow us to put in percentiles and then enter in our data. So 1,146 and 71. Let's go ahead and enter it in. I believe that is correct. Let's take a look. That is correct. Now, the first question asks us, what is the 51st percentile? And actually, I think I can guess this one because the 51st percentile is going to be very close to the 50th percentile. So if it wants whole numbers, I think I can do this one. To a whole number? Wow, this is a nice and easy question because it's going to be so close to it. And we can view that right here. Let's go to our applet and put in the 51st percentile, and we have to be very careful that we select the right choice because we want to see 51% below. If you notice, that is right at the 51st percentile, and it's actually 1,148, but the leeway gave it to me, so thank you, leeway. And now for this problem, what is the 97th percentile? And once again, I actually think I can guess this. I'm getting really lucky with the questions today. The 97th percentile is going to be very close to the top 2.5%. And that's going to be over here at 1288 is the top 2.5%. So I'm going to go to 1284. Let's see here. I'm going to put that in for the moment as a placeholder. I'm not so sure on this answer. So this is the important part. If you can kind of understand what you're going to get before you enter it in, you know you understand the normal rule, or the empirical rule, excuse me. And I was wrong, but I was close. So it rounds to 1280. So let's put back in here 1280. Close, but no cigar. Now we need the IQR. What is the IQR? The IQR is the middle 50%. That's what the IQR is. And you can display the IQR on here by showing the middle 50%. All we need to do is type in 50 and do between. Now the IQR goes from 1098 to 1,193, and this would have a span, this would round to 194, and it looks to have a span of about 96. You can subtract the two numbers, Q3 minus Q1, a little bit of practice there to make sure you've done it correctly. So that is how you practice up and find your IQR. And Q3 minus Q1 would get 96 right here. Once again, there's so many ways to use that applet that you have to be careful because when it comes to test questions, we might show you pictures of the applet. We could basically have you find the IQR by just giving you this right here, the below, and giving you this Q1. This is Q1, and if you know the median is the mean, because in a unimodal symmetric data set, the mean and median are the same, then the Q3 would be the same distance. Basically, twice the difference to the mean, because this is the 25th, 50th, and 75th percentile, would be the IQR. So if you just doubled this distance to the mean, there'd be a very tricky test question right here. It'd be like, use the following information to find the IQR. Well, you could take the median minus Q1 and then double that, because that's half the distance right there. And that does not work in other data sets. It's just because this is the normal curve. You can't do that formula for non-symmetric data sets. It's just because this is unimodal symmetric normal data. But that would be a tricky question. Just to reassure you, Q3 minus Q1 is the formula that always works. And so use that for the other chapters. Here we are with cholesterol levels, and it has a mean of 188 and a standard deviation of 24. Find the right model. And it looks like all the numbers are in order, 68, 95, 99.7, but we need 188 at the center and standard deviations of 24. And it looks to be this one is just right. It goes down 24 each time. The other ones go down too little or too much. What percent of adults do you expect to have cholesterol levels above 190? So now we need to use our model and 188 and 24, and we need to enter in the numbers. So this is where you make the switch back to the other one, and we enter in 188 and 24, and we do above 190, and that's very close to the center, so it's going to be very close to 50%, but less than. So this is above 190 with a mean of 188 and a standard deviation of 24. And you'll notice that this is the same exact graphic it shows us. And the answer is 46.68%. Make sure to enter in 2 decimals. What percent of adults do you expect to have cholesterol levels between 170 and 180? I like looking at the David M. Lane. 170 to 180 is in between here. So that has to be less than 34% because in this area is 34%. So let's go between and 170 to 180. Always good to estimate. And probably, oh, is it already showing me the answer? Nope. But as I said, it's less than 34% because that whole area between -1 to 0 z-score is 34%. And once again, you should, during the test especially, write in 0, 1, 2, 3, -1, -2, -3, because that's your z-scores. So 14.28, 1/7. So 14.28. Estimate the interquartile range. So now we need to give one number. Remember, the IQR is a number. The middle 50% of this data has a spread of blank. That is what the IQR is. And it's not too hard to find, but we're going to have to go to the other one and re-enter in 188 and 24. And let's put in here 50% to make it easier on the eyes. And go between. And the IQR, we can do the formula this time. Go on here and go 204.181, that's Q3, minus Q1, 171.819, hit enter, and it's 32.362. And it wants us to round it, so 32. Make sure to round and enter in the right decimals. Double check to make sure your answers look like this. Above what value are the highest 15%? So now we want the highest 15%, which is very close to the highest 16%. So it's going to be something about 213. So the highest 15% is going to be, and we want above that. So as I said, 213, it's 212. Could have guessed very close to that. And round, we could have got that by guessing. Once again, I want to point out why I know that. Going back and looking at the problem, we know the highest 16% according to the empirical rule is right there. The empirical rule states that 68 is in the center. That would leave 32 total on the outside and 16% above this. So the highest 15% is very close to that. Very, very close to. Let's look at the last problem here. We have the heights of kindergartners. What fraction of kindergartners should the company expect to be less than 36 inches? So now we need to enter in the observation, and we need to put in the normal model of 39.2 and 1.9. Once again, it's very important that it tells us it's normally distributed. It can be described by that. 39.2 and 1.9. Let's go back to where we can enter in the observations and do 39.2 and 1.9. And it wanted less than 36, I believe. Now I'm going to wait to hit enter here. It won't show up until I do that. 36 is very close to -2 standard deviations, and below here is 2.5% of the data. I'm going to say somewhere around 4.5%. Oh, yes. Very close to today. Maybe could have guessed that one. But it had to be more than 2.5 and less than 16 using the empirical rule. Always good to make guesses and make sure you understand. 4.6. Sometimes we ask a question that uses the empirical rule, and sometimes we give you the pictures. So that's why I do the guessing game, just for practice. In what height intervals should the company expect the middle 90%? So we just go here. And once again, we have to go to the other side of it. So let's go here. 39.2 and 1.9. And now we need the middle 90%. And let's go to here to between. And there we go. 36.07, 42.32. So to round to one decimal. 36.1, I think it was 42.2. Cross your fingers. Got it. at least how tall are the biggest 25% of kindergartners? It should say tallest. And we're on the right path already. Let's go here. So we need the tallest 25%. Once again, we could do this by doing the shortest 75%, and there's the same answer. Lots of ways to answer this. Very important to know that. 40.5 when we round to one decimal, which I believe it asks us to do. Let's go here. 40.5. And that has it. Good luck.